Fair warning, some of this doesn't leave you.
Number 10. Dark Forest Theory. You're the one who lit a campfire in a black wood and forgot to hide the smoke. In that image, the wood is the galaxy, and every other civilization, a hidden hunter. The rule is brutal. If you make yourself known, you become a target. Every intelligent species that broadcasts or builds something massive risks being spotted by something far stronger. Game theory says the safest move is silence. No calls, no signals, no giant engineering projects visible from 1,000 light years away. Stay invisible. Survive. Why do serious people take this seriously? Because it turns the Fermi Paradox from a curiosity into a survival problem. It explains radio silence without assuming life is rare. It just assumes life is smart enough to shut up. And it matches something we've seen play out in our own history. When strangers meet under unequal power, the weaker side doesn't usually get a welcome party. But the theory has costs. If everyone hides, no one cooperates. If one civilization breaks the rule, the whole neighborhood pays. The thought that our backyard radio chatter could be a dinner bell in a dark forest? Already chilling. And the worst part is still coming. If this rule holds, our signals since the 1920s have been leaking into space like a flashlight in fog. Scientists who worry about active messaging aren't being paranoid. They're imagining a predator that reads signals the way we read weather reports. Stephen Hawking warned about exactly this. He said announcing ourselves could invite trouble. That's the payoff. Silence might be the price of survival. Now, there are ways to push back. Hiding on a galactic scale is hard. Old civilizations would leave traces. Waste heat, dimming stars, something telescopes could catch. And game theory assumes perfect logic with perfect motives. Real societies are messy. Critics like astrophysicist Milan Cirkovic argue a mix of behaviors would break the whole dark forest picture wide open. Still, one reckless transmission could change everything. And that thought doesn't leave you. For us, the decision is urgent and deeply human. Do we keep quiet and hope to survive? Or do we speak up because curiosity is who we are? Either choice has costs, and the rules of a cosmic game we barely understand could shape everything that comes next. Number 9. Zoo Hypothesis. You walk through a zoo and the animals look right at you, but the glass keeps you apart. Now flip it. The zoo idea says the galaxy might be doing the same thing to Earth. Advanced civilizations watch quietly, study us, and refuse to interfere. Sit with that for a moment. Far older species could be monitoring planets with invisible probes or sensors we can't detect. They collect data, learn how we think, and make sure we don't break ourselves with sudden knowledge. MIT radio astronomer John Allen Ball proposed this formally in 1973, and the logic hasn't aged badly. The reason is simple. Contact can be a catastrophe. New tech or new ideas can wreck cultures overnight. Ball called it quarantine for our own good, and there are real echoes of this in serious debate. Astronomers who worry about beaming messages into space mention caution. Ethicists compare first contact to colonial encounters on Earth, where the meeting usually destroyed the less advanced side. That makes the zoo idea not a fairy tale, closer to a policy someone already thought through. If Earth is under observation, then every strange sighting could be a window into our enclosure. But, and this is the uncomfortable part, who decides when we're ready to leave the exhibit? Not us. Scientists push back, and they should. Hiding a whole planet in plain sight across cosmic time would be fiendishly hard. We look for waste heat, odd light signatures, giant engineering projects. So far, we find none. The zoo idea needs a universal rule among total strangers, and a patience measured in millennia, which is asking a lot of any civilization, even an ancient one. Still, the hypothesis answers a worry that doesn't go away. History shows that sudden exposure to alien technology or ideas can topple societies. Ethicists in the METI community, the people who debate whether to send messages, argue that non-interference isn't just reasonable, it's responsible. But the part that sticks is moral. If others are deciding when we may join the wider community, then our future is being judged without our consent. What we learn, when we learn it, whether we're ready, all of that could be decided off-world. by minds we've never met. So ask yourself, which is worse, being alone or being managed? Number 8. The Great Filter. You look at the fossil record and see 5 mass extinctions. Now imagine aliens see the same pattern across 1,000 worlds, and they know why. The Great Filter says there's a wall between where we are and where interstellar civilizations should be. Something kills species before they make it, and the civilizations that did survive, they might know exactly what that wall is. Economist Robin Hanson proposed this in the late 90s. The math is simple. The conclusion isn't. The universe is 13.8 billion years old. There are billions of habitable planets. Statistically, the galaxy should be crawling with advanced life. But we see nothing. No megastructures, no engineering projects big enough to dim a star, no signals, no visitors. Hansen argued there must be at least one nearly impossible step somewhere in the journey from chemistry to civilization. He called it the Great Filter. The terrifying question, and this is the one that keeps people up, is where the filter sits. If it's behind us, maybe the leap from single cells to complex life was the hard part, and we already cleared it. That's the hopeful reading. But if the filter is ahead of us, then every civilization that reaches our stage eventually destroys itself. Nuclear war, runaway AI, ecological collapse. Pick your poison. Now, and this part doesn't get talked about enough, if older civilizations passed through the filter and watched others fail, they'd carry the most dangerous knowledge in the universe. They'd know what kills worlds. And sharing that knowledge, it could be mercy. Or it could be handing someone a loaded gun. Imagine telling a young species how to build unlimited energy and also handing them the blueprint for unlimited destruction. So the survivors go quiet, not because they're cruel, because the information itself is the weapon. Imagine watching 1,000 civilizations blow themselves apart after learning the same lesson. At some point, you stop teaching. Hansen later expanded this with a model he calls grabby aliens, civilizations that expand fast and visibly. The math suggests we appeared about when you'd expect if grabby aliens exist, but are extremely rare. That means the filter is severe. It claims most species before they ever get the chance to expand. What this means for us, and I keep coming back to this, is that we might already be inside the filter. Climate tipping points, engineered pathogens, artificial superintelligence. Any of these could be the wall. The aliens who made it through aren't hiding from us. They're hiding knowledge from us. Knowledge about what comes next and how almost everyone fails. The part that stays with you isn't that we're alone. It's that the answer to why we're alone might be a warning we're not ready to hear. Number 7. The Berserker hypothesis. You send a radio signal into space, and something listens. Not a curious scientist, not a friendly diplomat, a machine. Old, patient, and built for one purpose, to find emerging life and end it. Remember the dark forest? Now add machines patrolling it. The Berserker hypothesis says the galaxy might be stalked by self-replicating killing machines. The name comes from Fred Saberhagen's 1963 science fiction series, but the science underneath is real. Mathematician John von Neumann showed that a machine could harvest raw materials from asteroids, build copies of itself, and launch those copies toward new stars. 1 becomes 2, 2 become 4. Within a few million years, a blink cosmically, the entire galaxy is covered. Now add a single instruction: destroy any civilization that broadcasts. Astrophysicist David Brin pulled this into serious scientific debate in his 1983 paper, The Great Silence. He argued that a paranoid, or long-dead civilization could have launched these probes as a permanent defense system. The creators don't even need to exist anymore. The machines just keep going, forever. And that's where it cuts deep. If Berserker probes exist, then every civilization that survived did so by going dark. They learned. Don't broadcast. Don't build anything visible. Don't attract attention. The galaxy isn't empty. It's a minefield. And the survivors are the ones who stopped making noise, which makes our behavior look reckless. We've been leaking radio signals for over a century. We sent the Arecibo message in 1974, deliberately aimed at a star cluster. We strapped golden records to the Voyager probes and launched them into interstellar space. If something out there hunts by signal, we've been waving a flag from the hilltop. Critics argue that if these machines existed, they should have reached Earth by now, given the age of the galaxy. Fair point. But others counter, maybe they're dormant, waiting, triggered only by a signal strong enough to register as intentional. That gives us a chilling answer to the Fermi Paradox. We don't see alien civilizations because the machines got to them first. And the ones that remain? They're not hiding from us. They're hiding from the machines. Their silence isn't indifference. It's survival. This is one of the strongest arguments against active SETI. The idea that we should listen but never speak. That caution isn't paranoia. It's what a universe like this would demand. Number 6. Aliens hiding among us. You pass someone on the street and their face is ordinary. What if ordinary is the disguise? People have asked this for years, but it's not just late-night radio anymore. Researchers like Harvard's Tim Lomas have published work on what he calls the crypto-terrestrial hypothesis. And astrophysicist Avi Loeb's Galileo project has pushed adjacent questions into mainstream science. Not every stranger is non-human. Something more precise, that a small, highly advanced population could be moving in stealth. Evolved cousins, survivors of lost lineages, or, and this is the twist, humans from the far future who learned how to slip back and observe their own past. Why does this sound plausible to some experts? 3 reasons, and they're worth laying out. First, detection depends on shared signals. If an intelligence uses signals we don't search for, we miss them entirely. Second, recent work on crypto-terrestrials argues that some UAP reports fit patterns of local, hidden activity rather than long-range visitation from distant stars. Third, the time traveler hypothesis explains something specific that other theories don't. Why so many reports describe humanoid figures rather than wildly alien anatomies. If the visitors are our descendants, they'd look like us. Because they are us, just later. They could be hiding in plain sight, blending into cities, running research, living under layers of social noise. It stops sounding like fantasy when a Harvard astrophysicist frames it as testable. And that's exactly what Loeb's group has done. Skeptics push back hard, and they're not wrong to. They point to folklore, pattern matching, and evidence that wouldn't survive peer review. They want clear, repeatable data. So do I. But even if the chance is small, this stops being abstract fast. Shared space means shared rights and shared risks. Who decides disclosure? Who protects the people who aren't ready? The dangerous idea isn't that they exist. It's that we wouldn't know if they did. Number 5. Alien satellites and ancient artifacts. You read a story online that an object has orbited Earth for thousands of years. The name people whisper? The Black Knight. I'll be honest, this one's more campfire story than peer-reviewed science. But it won't die, and there's a reason for that. The Black Knight tale blends old radio anomalies, misidentified debris, and a clutch of strange sightings into one tidy legend. Early reports and odd photos were reinterpreted through decades of rumor, until the whole thing hardened into myth. Some point to Nikola Tesla detecting strange signals in 1899 and stitch that into the story. Others look at shapes in satellite photos and call them artifacts. Then there are the ancient astronaut claims, megaliths and creation myths reread as evidence that visitors shaped the distant past. Serious scientists note simpler explanations, space junk, misread pictures, cultural storytelling that fills gaps with gods from the sky. Archaeologists say extraordinary claims need extraordinary proof, and so far, the proof is thin. But the legend persists because it offers something powerful, a single, spooky answer to a deep question. What if someone's been watching for a very long time and chose not to introduce themselves? Even so, hold wonder and skepticism in the same hand, and don't let go of either. Number 4, the planetarium hypothesis. You look up at the night sky and see billions of stars spread across an empty void. What if that emptiness is the lie? The zoo had glass walls you could at least press your face against. This cage, if it's a cage, doesn't even have walls you can see. Stephen Baxter, British physicist and author, formalized this idea in 2001 in a paper published in the Journal of the British Interplanetary Society. The argument goes like this, and it's uncomfortable. If a civilization is advanced enough to harness energy on a galactic scale, what the Kardashev scale calls Type 3, then projecting a fake sky around one small planet isn't engineering, it's arts and crafts. And inside that projection, you'd see exactly what we see: empty space, no signals, no neighbors. The Fermi Paradox isn't a mystery to solve, it's a screensaver. Why would someone do this? Baxter suggests several motives, and none of them are kind. Containment. If a young civilization believes it's alone, it has no reason to expand aggressively. Protection. Contact with a vastly superior culture can shatter a society the way colonial encounters shattered civilizations on Earth. Control. By shaping what a species can observe, you shape what it believes is possible. Let that land for a second. Every telescope reading, every deep field image from Hubble and Webb, every SETI scan coming back empty, all of it could be reporting exactly what the architects want us to see. The laws of physics we test might be constraints written into the simulation. The cosmic microwave background, the expansion of space, the distances between galaxies, set dressing, all of it. Physicists like David Kipping at Columbia have proposed looking for seams, glitches in quantum mechanics, unexpected limits in the precision of physical constants, strange patterns in cosmic surveys that break the rules of random distribution. If the projection has edges, there might be ways to find them. Critics say the whole thing is unfalsifiable. You can't disprove it because any evidence could be planted. That's a fair objection, but honestly, it makes it worse. If you can't test the walls of your cage, you can't prove the cage doesn't exist. The planetarium hypothesis doesn't hide a signal or a warning. It hides the universe. The real one. Other civilizations, other forms of life, possibly a reality far more crowded and strange than the empty sky we think we inhabit. The emptiness of space might be the greatest illusion ever constructed, and we're sitting inside it, convinced we're alone. Because that's exactly what someone wants us to believe. Number 3. Alien silence as a protective measure. You shout into a dark field and hear only wind. That silence might not be absence. It might be policy. This one feels different from the others, less about predators and probes, more about something almost parental. The idea that someone out there made a deliberate choice to leave us alone. Not because they don't care, because they care too much to make contact. Broadcasting your presence can be an invitation to trouble. We covered that with the Dark Forest. But there's a quieter fear underneath. A message that reveals your location could bring slow-moving machines that arrive centuries later. It could spread ideas that damage a culture without meaning to. Hawking warned about this. So did a number of less famous but equally serious thinkers. Then there's contamination. Contact could introduce microbes, concepts, or technologies that break social systems from the inside out. Think of what happened in history. When advanced societies exposed isolated peoples, the result was almost never a blessing. It was collapse. A related idea is the information hazard, a concept from risk theory that's gotten a lot of attention lately. Certain knowledge isn't just powerful, it's dangerous. A piece of physics that unlocks unlimited energy could also unlock a weapon no one can defend against. From that view, silence isn't cruelty, it's quarantine. Clinical, careful, and deliberate. If this is true, we face a choice, and it's ours to make. Do we keep whispering into space, or go quiet to survive? The answer isn't obvious. If silence is protection, then broadcasting without global agreement might be the most reckless thing our species ever does. Nations, scientists, citizens, we all share the risk. You send one message and you announce your location for centuries. That's not a private decision. There's a moral question underneath all of this that I don't think gets asked enough. If other intelligences hide to avoid causing harm, do we protect ourselves by staying quiet? Or do we risk everything to learn more? This isn't a thought experiment anymore. It's a public policy problem about risk, communication, and who gets to decide for 8 billion people. Number 2, the transcension hypothesis. You search the sky for alien megastructures and find nothing. You listen for radio signals and hear silence. What if that's because advanced civilizations aren't out there at all? What if they went inward? I'll admit, this one bent my brain the first time I encountered it. Futurist John Smart proposed that as civilizations advance, they don't expand across the galaxy, they compress. They move towards smaller and smaller scales of space, time, energy, and matter, what Smart calls stem compression. Think of it as squeezing yourself into smaller and more powerful boxes. Instead of building outward, they build inward. Instead of colonizing planets, they colonize physics itself. Picture the trajectory. Early civilizations use fire and stone, then electricity and silicon, then atoms and quantum states. Each stage is smaller, faster, more efficient. Smart argues this trend doesn't stop, it accelerates. The endpoint isn't a Dyson sphere wrapping a star. It's something far stranger, a civilization that compresses itself into the densest computational environment possible. The final destination? A black hole. That sounds extreme, and it is, but the physics has implications worth sitting with. Black holes offer maximum computational density in minimal space. They bend time, which could enable forms of forward time travel. Some models suggest they might even seed new universes. If you wanted to build the ultimate thinking machine, you could do worse than falling into a singularity on purpose. This explains the silence in a way that doesn't require predators or paranoia. We don't detect advanced civilizations because they've transcended our observable universe. They didn't go quiet out of fear. They left. Not into the stars, into the subatomic. Running civilizations on scales we can't measure with any instrument we possess. And the hiding? It's not even intentional. They're not concealing a message or a warning. They've moved to an entirely different mode of existence, one that's invisible to any species still looking outward. We scan the sky for waste heat and radio leaks. They produce neither. They're running at efficiencies we can't imagine, in environments we can't detect. Smart argues this isn't one species making a quirky choice. It's a path the physics pushes every intelligent species toward, like water finding the lowest point. The physics rewards compression, so every sufficiently advanced civilization follows the same trajectory. If he's right, the galaxy isn't empty. It's full of transcended minds hidden inside the smallest structures in the universe. And we can't see them for the same reason an ant can't see the internet. The infrastructure is everywhere, but the ant doesn't have the sensors to notice. The chill isn't that they're hiding from us, it's that they've moved somewhere hiding is automatic. We're left standing on the surface of reality, shouting into the dark, while the real civilization is happening in dimensions we haven't learned to look at yet. Number 1. First in, last out. You look for aliens and find silence. What if the silence isn't because something destroyed them? What if we're the thing that will destroy them? We started this video worrying about predators in the dark forest. This last theory says the predator might be us. Russian physicist Alexander Berezin published this in 2018. He called it the first in, last out solution to the Fermi Paradox, and the logic is brutally simple. The first civilization to achieve interstellar capability will, by the sheer nature of expansion, eradicate all other life in its path. Not because it hates what it finds, because it doesn't notice. Picture a construction crew building a highway through a forest. They don't hate the anthills they bulldoze, they don't even notice them. The anthills are simply in the way. Berezin argues the same dynamic plays out at a cosmic scale. A civilization that builds self-replicating probes or harvests energy across star systems will consume the resources other emerging species need. It reshapes environments and crowds out competitors, the way an invasive species overwhelms an ecosystem. And it does all of this without malice, because the competitors are too small or too slow to even register. And here's where it gets truly dark. Berezin says the reason we don't see aliens is that we might be the first civilization to reach this threshold. We're the ones who will eventually expand, and when we do, we'll be the accidental destroyers of every other form of life trying to emerge across the galaxy. He calls that outcome worse than extinction. Our own extinction would end our suffering, but being the species that unknowingly wipes out a galaxy full of potential civilizations, that carries a moral weight that's almost unbearable. Accidental genocide on a cosmic scale, and we won't even know we're doing it. The theory requires almost no assumptions. It doesn't depend on alien psychology, alien biology, or alien motives. Just one parameter, the drive to expand. Berezin argues that whether the expanding entity is biological, a superintelligent AI, or a planetary-scale hive mind, the result is the same. Growth consumes, and the first to grow wins by default.
Other scholars push back.
They argue intelligent species might choose restraint, that ethical frameworks could limit expansion, that civilizations might federate rather than consume. But Berezin points out it only takes one species, one AI, one runaway replication event. And across billions of years and billions of planets, the odds favor the aggressive expander. This theory hides something from us, but the thing hidden isn't out there. It's inside us. The most dangerous entity in the galaxy might be our own trajectory, our own ambition. We search the sky for monsters, and the theory says the monster is in the mirror. The silence of the cosmos might not be a warning from aliens. It might be a preview of what we're about to do. Which of these 10 theories chills you the most? Tell us in the comments and tell us why.